Hello and welcome to another video. So once again I'm going to be taking a look at a previous game I have worked on and talking about design decisions, talking about also the code processes for that and sharing a bunch of that code as well. So let's dive on in. This particular game was one that, again, I developed under that process of having a budget of 24 hours. And this was for, like I was using, wasn't for Global Game Jam, but I was using the Global Game Jam theme of repair for this. So in terms of what you actually do in the game, so what you have is you start out in this rock shaft. You're on this platform and the platform is slowly moving up and you have these different motors here. We can see most of these indicate that they're failed, but the emergency brake is working. Terminology could have actually been better with this, but those are all going. We've got one motor that is working, but the rest of the ones are not. So the idea is, and this is the reason why there is that distance counter going up, the idea is to essentially manage to climb as high as you can. So each of these motors, you need to come over and repair it. So two parts of it can break. The emergency brake, which I also have just realized the spelling of that. So, yep. I should maybe fix that and do an updated version. Can't believe I completely missed that I had that spelling mistake in there. So once again, doing one of these videos, I've learnt things that were broken. So, as you can see, with repairing stuff, the platform starts being massively tilted. So this is something where, while I am moving faster because I've repaired things, I'm also on a weird angle because I haven't repaired things in an even way. So the goal is to essentially get as many of these repaired as quickly as you can so that you can get as high as possible. But the repair is a hold action. So you have to actually be doing that for a while. And that's, again, an intentional thing because the goal was to make it actually take a while so that you have to have that sort of challenge and that difficulty of it's hard to keep up with. And there are things that can happen, like rocks can fall, and that happens sort of periodically, and that does damage and can actually mess with the motors. So we can see there's a few rocks there. They can also stay on the platform, which again makes it a bit more difficult for moving around. So the goal is you try and actually get everything repaired. Whoops. And that looks like I have all of the things are failing, so it's not moving. If I get something repaired, it might just be enough time for it to start moving. So it is a little bit, but a lot of things are broken. And so this is sort of the increasing difficulty that you face with it, is more and more bits will break, and that can affect how quickly you're actually moving. And the repairing also requires you to be continually focused at it. So, I think from a design point of view, there were a bunch of parts that I was really happy with how they worked, in that I liked keeping people's focus on this, especially when a rockfall happens. Having it that people are focusing on something is sort of, I think, good. I like that the rocks do actually have physics on them, so that they do provide a bit of a blockage and do make things more difficult. And so parts of it I think worked really well. Obviously, there are parts like my terminology there is not particularly accurate for what I've described for a bunch of the things. And I still can't believe I have break spelt wrong in this. And you can get to a point where you have fully repaired everything, but there you're more likely to encounter rock falls and things like of that the longer it goes, and the platform's going to become more filled with rocks. And you can't just only repair one motor and just focus fully on it, because the actual speed that these break at is down to essentially the load that each component is carrying. So the higher a level of sort of strain it's carrying, the faster it will actually break. So that's an intentional thing, that it does get a little bit easier as you get more things repaired, and having that for each side, that 2-tier of things. I think there's definitely more I could have done in terms of, there we go, some more rocks falling. So they do a lot of damage and knock things around. And you can also fall through. So I think there was things there I could have done to, again, improve the design side aspects of it. I think having more things than just the rocks falling, having more distractions that can happen there that impact on sort of what you're doing, as well as also having it that you're a bit more feedback, because there's not a lot of feedback of what's happening. You're kind of having to rely on green or red text, which is not really good. It's not going to work for if folks have things that impact on their color perception. So that's not great. Yes, they could read the text, but if you're going for something where it's a very quick sort of scan, that's not going to work very well. So I think ultimately what I should have done is have things there like sparks and smoke, other sort of visual indicators, and used iconography. I think would have made it easier, because even my color perception is works okay, but even with that, I actually find it difficult to, in the moment, quickly recognize where to head to. So I think that would have helped a lot. So particles, iconography, things like that would have made it a lot clearer and easier. Having a bit of more variation in terms of what stuff happens during while you're actually playing the game. And a few more things, like I like the rocks piling up, and I think actually, like I didn't have as many because of the difficulty there in terms of the performance concerns with that many physics bodies, but I think actually should have had more. And I think even doing things like maybe knocking out sections of the actual platform would have been great, because then what's happening is as those areas get taken out, it becomes more difficult. So you've got a bit of an increasing difficulty, and it's actually having sort of a cool gameplay visual associated with it. So, okay, let's look at some of the actual implementation side of things for this. So, haptic feedback was a big aspect of this, and there's a lot of haptic feedback actually happening. And this was a game where I did make some major updates to my haptics manager. So this is something I'll include the code for this in the actual in the link in the various segments of code that I provide. The haptics manager will be part of that, because one of the things I did with this was a lot of stuff with being able to support timelines and additional capabilities in terms of durations, things like of that it could actually do. And if we go and take a look at the actual sort of haptic effects we've got, I set up specific ones for things like, okay, if the limiter has failed, and that's actually the break there is actually supposed to be referred to as the limiter. Motor failed, has haptic effect as well. The platform, when it's ascending, there is a looping haptic effect that plays, and rocks also kick off a haptic effect. So all of these were set so that they could actually blend. And in terms of where they actually fire off, I can remember exactly where I set this up. Probably, okay, on the actual rock script, potentially. So these would launch. That's right. And then the platform would get told that it was hit. So I'd be able to play these effects. So when a rock hit, so they'd get launched from various locations in the world. And we likely can sort of see those spawn points. Take a look at the scene view. So we had a bunch of spawners just scattered around. And if I add spheres to those so we can actually see where they are. I'll do the same with the second set because the second set also spawned rocks. So we'll give those a sphere also. So we can see scattered throughout here, it's essentially a whole bunch of these spawners. And so the rocks would fall, and because they're spawning from different ones, they land at different times. So when a rock would hit, they would figure out where it is relative to the motor. So it was essentially finding the closest motor. And if it was close enough to it to actually cause stress, then it would apply stress to that particular motor. So the motors had this concept of stress. And there was a certain amount of stress that was, if it was below a certain amount, the limiter would fail. And we also had the motor failing, so that two-tiered approach if stress got added. So if we take a look at how that worked when we're adding stress, if we go to stress, if the motor is active, then it's applying stress to the motor. If that exceeds our maximum amount, then we fail it. Otherwise, we might have our limiter still active, the poorly named brake. So if it's active, we build up stress. And then if it reaches failure point, then it tips over. Now, important thing with this would mean that if you got a big burst of stress, it wouldn't automatically then go and just sort of fail out the motor. So it didn't sort of carry over. We did reset things like the stress on the particular one. So if I repaired the motor, it reset that. So that worked quite nicely for being able to handle that concept of stress. So the platform handled if a rock was hit. As far as it moving, this was actually quite a bit of logic to sequence sort of the moving and things like of that. So first thing it did was it figured out what speed we were going at, which that speed was down to how many motors were active. So if a motor was active, that was directly contributing a bunch of speed there. If there were limiters active, that contributed to how many things were active in general. If we actually sort of hit a target speed of 0, we'd drop the current speed immediately. We wouldn't try and lerp to it. So the idea there was if, for whatever reason, we were moving and then a motor gave out, and so we should suddenly stop, that it wouldn't do a move towards on the acceleration, that we'd get that juddering, sort of jarring stop. And that was synced with some haptics, so we got some pretty good feedback to the player there. And that haptic feedback, again, that was a big core part of this. So speed, we'd have limits to acceleration, and that was sort of modified by speed. We had haptics that would kick in if we were moving. If we weren't moving, we just stopped them. So this ability for having these GUIDs and starting and stopping it was part of it with the haptic system. And then we also wanted the platform to tilt. So if different motors, different things like if that were active, that contributed towards the particular vector. So how I approached this was from the center of the platform, it would figure out a vector that is sort of from that motor, and the Y component would get changed based upon if the motor was fully active, if the limiter was active, or if the motor was fully broken. And we can see those particular values if we take a look at the platform. So fully active would contribute 2, limiter 1, fully broken 0. And that would allow it to then tilt. So we just combine all of those, normalize it, and that gave us the new up vector. Now, it would, with that new up vector, it would just, if we had it turned on, reorient immediately. Now, I'm trying to remember what the criteria was for reorienting immediately. I suspect, because it has been a while, so fixed update, it wouldn't orient immediately, but initially, okay, so in most cases, it wasn't going to reorient immediately. So it'd only do it when the game actually initially launched, which makes sense. So otherwise, what it would do is it would just actually figure out that reorientation and do that tilting a little bit over time. So that worked out quite nicely. Now it would figure out the sort of stress. So there was a base amount that would always get applied. There was an amount due to speed. So as we were going faster, that would apply more stress onto things. So fixing more things would also increase the amount of stress. And then we'd look at that per unit and go and apply that stress to the units. The amount of stress there was dependent upon the number of ones that were active. So if you had more active, then each one would get less stress per actual one. So that was sort of the incentive for trying to repair more things and not just tunneling on one. Because if you tunneled on one, it was going to take, it was essentially going to be getting a very large amount of stress applied to all of them. So that full stress that gets calculated is all going to each individual motor. So it becomes very difficult to maintain it. So it did get a bit easier over time. So that's how sort of stuff like the platform tilting, things like if that worked, and how stuff in terms of the stress. So we had stuff there in terms of the impact as well would have an effect. Now, the rockfalls, we obviously had the prefabs for them and the spawners, but we did keep track of how many active rocks we had. And we did make it that what it would do, if we go and take a look at this. So if a rockfall was happening, there would be an interval before it would spawn another rock. And that was randomized. And we would then have, if we'd finished spawning all of them, we'd have a random amount of time until it actually kicked off the next rockfall. So that was based upon just that time between falls. And that was based upon things like our speed. So if we hadn't queued up a rockfall, then we would adjust when that time was until the next one, but that would scale with the current speed. So as you were moving faster, that was going to be scaling things up. So that would be increasing the time contribution here. But we then also had this time reduction with speed, which if we take a look at that, that was 1.5. So what that means is the faster you are going, the faster it's going to be that this time is elapsing. So the speedier you go, the less the interval between rockfalls, essentially. And again, that was intentional. The idea was if you manage to get the platform going really, really quickly, then it needs to become more difficult. So it was a way to try and be pushing back against the player, but pushing back in a way that was sort of, I guess, subtle and a bit more indirect, and a bit of a gentler pushback against the player. So it wasn't, directly punishing, them doing well. There was still an advantage to them doing well, but it did mean that the stakes rose, and that was a key part of it. We did, any rocks that fell below the platform did cull them, so that was pretty important to make sure that was happening. It happened only once they were more than a certain distance below the platform, just so we couldn't see them. But that worked quite nicely. In terms of launching them, it would pick a random point to be launching at and a random force, and then that would work for sort of picking places where it would go and hit. So that worked quite nicely. But the thing you might also be wondering is, like, this rock shaft is a pretty decent length. Like, there is a lot of distance to that. And this was one of the things that I was running into. There was a lot of balancing with this in terms of lighting level, and also being able to have an environment that you're moving in that looked, correct, but also was actually able to run with any level of performance. That was a big challenge. So what I did, because these are all meshes, like these, every single one of these is an actual mesh. So I had to be careful with the amount of meshes that I was bringing in, and I had to be careful with sort of the rendering settings and that of them to try and have it that it was going to run with okay performance. So what actually happens is we have a prefab for the segments, and we periodically spawn in new ones. So the shaft manager, and this ends up being a little weird, it manages the cables as well. So these cables, because if we look, we'll notice the cables actually appear like we are moving up them. And that's intentional. The shaft manager is the thing that updates that. Not really the best way of doing it. So all I'm doing is I'm scrolling the texture. So I adjust the texture offset, and that creates the illusion that it's actually moving along those cables, even though it's not. The cables all, if we take a look at them, those cables all actually end a chunk of a distance up. So they don't actually loop forever. So that was a way of sort of hiding that. So it updates the cables, and how far it moves is based upon whatever our current speed is. For the shaft, there's a similar process there. So what it does is the platform itself doesn't actually move. It does pivot, does twist, but we don't move the platform. This is one of those cases where, while it looks like we're moving, if I go and actually select the platform, and I'll bring the game view down here, just so that we can actually watch it. So what we'll notice is the platform doesn't move. The thing that's moving is these segments. And if I move out of the way here, you can see it's spawned in a whole bunch of additional ones that weren't already there. And as I keep moving further up, what it will do is it is despawning segments that are below us a certain distance that have gone out of view, and spawning in new ones. So this isn't necessarily appropriate to all games, but if you do have something where, and then we saw one spawn in, if you do have something where there is that process of you're moving in essentially a scrolling environment, sometimes it can be easier to have the player or the area of the world that the player is anchored on actually stationary and you move the world around you. That was the case for this. It was a lot easier to, and a lot less risky from a physics point of view. Because bear in mind, those rocks were physics objects. The player is a physics object. So having a platform that could rotate or tilt and having things on it that also would then be moving with it. If I had the platform move while doing that, that gets a little bit trickier and can be more prone to running into issues. You need to be very careful with how you move things in that case. Whereas, especially with moving them fast, whereas by having the actual exterior walls move, I could move them as rapidly as I wanted and it wouldn't break anything to do with the platform. So what I was doing was I was just going through and I had spawn and despawn values and I would just check and see, okay, if something's below the despawn point, goes to the remove list. If I need to be spawning ones, which was the default assumption, so if I didn't need to spawn ones, then I'd flag that. But if I did, I'd just spawn in a new one. So that worked quite nicely for having that sort of behavior there of the different pieces getting spawned in. So I was quite happy with that side of it. So there was a lot of bits that I think worked quite nicely in terms of that sort of feedback with the haptic side of things worked really well. There was a lot of reliance on the haptic feedback. I think the general sort of having, the environment scroll worked well, the rock falls and how I was handling the timing of those, I think that worked nicely. The bits that I really sort of wasn't happy with is I think, obviously the terminology on the labels, we've covered that. The visuals there, I think making use of sparks and smoke, having it visually look like these motors are maybe heating up, things like that. Something that provides a lot more visual feedback as to the state of stuff for being able to prioritize things, I think would have been helpful. I think it's easy to miss what you need to press for actually doing the repairs. Because if I go over to these, there is an indicator. So it does have an actual indicator there, but you only know that it's repairing by actually pressing the key. So yes, you can discover it, and most likely people would discover it, but not necessarily. Someone who's very new to games coming into this would quite reasonably not have any idea what to do. So I think that player training side definitely needed to be better with it as well. But overall, quite happy with how a lot of the stuff worked. This game was very much one where I really dived into that haptic side and trying to keep things simple, but also really dwell down on a particular area, that being the haptics. So I'm going to make a bunch of the code for this available. Basically, all of the various files that you sort of see here are ones that I will include. So the updated haptics manager, stuff there in terms of the motor, the platform. So you'll see things there in terms of how all of those bits of code work, and you'll be able to make use of those in any of your own projects. So as with any of the code I make available, you can freely use this in your own projects. No requirements there or limitations. There will be sections in the code that have dependencies on parts of code that I haven't been able to include, so I can't make the full project generally available because I am using third-party libraries, things like that, that I don't have the license to distribute. So I'll only be including the segments of code that are my own there. Thanks, folks. Hope you found the video interesting and helpful. If you have, check out like and subscribe. It really helps out. It's really appreciated. If you've got any questions, chuck those in a comment below. If you would like to see me cover information like this and any of the other small games I've worked on, chuck that in a comment also. If you're looking for the code that I mentioned, that code is available up on GitHub, and I've placed a link to that in the description below as well. And as I said, you can use that in any of your own projects, commercial and non-commercial ones. And if you are looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description as well. But until next time, bye!